In this episode of the Advanced Higher Maths course, we will look at how to integrate some more complex functions by using partial fractions. Now I'm going to be completely honest, this is the third time in a row I'm having to film this because my phone is having a little problem, I think, with filming, so I'm not going to spend too long on this video. So when we're going through the partial fractions, I'm going to assume you know how to solve partial fractions, and so I'm going to skip over the parts where the partial fractions are solved. So anyways, let's understand what we mean by integrating by partial fractions. So we're going to use this method when the integral is the general form p of x over q of x, where p of x and q of x are both functions of x, dx, and then we're going to try and simplify it to something maybe of the form a over f of x plus b over g of x, where a and b are constants in f of x and g of x are functions of x, and then we'll be able to solve the integral by using natural logarithms mainly, but also sometimes trigonometric identities if necessary. So let's get straight into an example. So let's say we're asked to find the integral of 5x plus 1 divided by x squared plus x minus 2 dx. Now I'm sure you'll understand that you'll definitely need to split this part into partial fractions, right? After all, the question is telling you to use partial fractions to find this, and also this seems like a very partially fractionsy type of question. So just solve this into partial fractions on your side. I'm going to press pause and go through the process, and then you can look at the working afterwards. Alright, so this is the partial fractions now. So look over the working. Hopefully you got to the same answer. This is not too tricky for partial fractions. And now we'll look at the more interesting part, which is actually integrating this. So now we know that the integral I, we're going to call it, is equal to, so we've transferred this to this, so it's equal to, I'm going to put brackets just so we make sure we understand it's all in one part, 3 over x plus 2 plus 2 over x minus 1 with respect to x. And this is much easier to solve, because it is just equal to 3 times natural logarithm of the absolute value of x plus 2 plus 2 times natural logarithm of the absolute value of x minus 1 plus c. Now the reason for this is because a general rule is that the integral of a over f of x, where f of x is a function of x of degree 1, so the highest power of x is 1, so it's not like a quadratic with x squared. So this is equal to a times natural logarithm of f of x plus c, but that's not too important for this. So basically in general, this can just be 3 times natural logarithm of x plus 2, 2 times natural logarithm of x minus 1, then we add the c on at the end. But that's not quite done, because you should know your laws of logarithms, and now you can simplify this further, because a times log b is equal to log b to the a. What I mean by that is this here, so 3 natural logarithm of x plus 2 is equal to the natural logarithm of x plus 2 cubed. Then this is simplified to x minus 1 squared here, plus c. And now we can put these under the same natural logarithm, because log a plus log b is equal to log ab. This is equal to the natural logarithm of the absolute value of x plus 2 cubed times x minus 1 squared plus c. Alright, and that is our final answer this time, because we cannot really simplify this further. You could expand the brackets, but that's not really simplified, that's just arguably more messy. So now we'll go over a second example. If we're asked to find the integral of x plus 1 squared divided by x cubed plus x dx, using partial fractions. So the first step is going to be to solve it into partial fractions. Now, I'm not going to go through this video once again, because there's a whole series of videos on partial fractions, so go watch them if you want to understand how to solve this fully. If you don't already, you should already, so press pause, have a go, and I'll walk through the answer. So here's the integral solved, the partial fraction, solved. It comes out as 1 over x plus 2 over x squared plus 1. So now back to the integral. The integral is equal to the integral of 1 over x plus 2 over x squared plus 1 with respect to x. Now, this is a bit more complicated than last time. This part, easy, it's just natural logarithm of the absolute value of x. But now here, it's a bit more complicated. Because remember, I said this only works for powers of 1, and here we have x squared. So it's going to be a bit more lengthier process or not necessarily lengthier, but more complicated. And so, if we come back to our standard integrals, we can see something very similar. We get that integral of 1 over x squared plus a squared is equal to something basically to do with, well, I'm just going to write it all out, 1 over a tangent inverse of x over a plus c. Now here, we actually see we have the same thing. Now the 2 is just a constant, so we can keep that. It's going to be plus 2 something. And then the 1 is a, so 1 over 1 is just 1, x over 1 is just x. So 2 tangent inverse of x plus c to finish off with. And we cannot simplify this because, well, tangent inverse and natural logarithm of x are non-compatible devices, to put it simply. See you in the next video to get a more cool integration with integration by parts.